My name is Luther Hill. I will be doing a talk today on delivering, using APIs to deliver machine learning, basically. So first off, I'm going to just I usually tell people in the beginning of these things, we're going to play a short video clip about what I think the current state of machine learning is. For any of you who've seen Silicon Valley, it's very much like that. And if you hear some running around, it's not me, it's my two very energetic cats. So bear with me. All right, so what you're seeing on your screen right now is just a series of imports I'm using Python Notebook. I tend to use it a lot for what I'm doing. A lot of what I'm doing is modeling and prototyping, so this works very efficiently for that. But really, any of the code that I'm using here, you can really use on any IDE or really anything that supports Python programming. It's not tied to any particular type of format or system or whatnot. Some other considerations: I'm using this on a Windows computer, but the code itself is not. There's nothing in the code tied to Windows. So the only thing tied to Windows is probably some of the file paths. Obviously, you're gonna have to change the formatting of that. But other than that, all the code you see here can be used on anything. All the code is available on my GitHub. Just go on to GitHub and search for Luther Hill. If you popped on LinkedIn, you can connect. I encourage you to connect with me, Luther Hill, on there. Or if you just want me to send you the code, just send me an email or something, and I'll send you the code. But all this code is available on LinkedIn. So the first couple of imports are just so we can set our environment, making sure that we have all the proper imports. I like to do that right off the bat to make sure that nothing is missed. With Jupyter Notebooks, it's easy to do that. The next two ones you see on there are just a basic show image kind of function. I want to make sure that all of my images are properly displayed. Some of the images I'm using are not formatted appropriately for a Windows system or on Jupyter Notebook. So by using this function, it just allows it to, no matter what photo I use or find from somewhere, I can display it and not have to worry about what format it's in or anything else. All right, so first thing we're gonna do is just cover a brief agenda, right? There's gonna be a quick bio about me. There's going to be 3 truths of data science as I see them. You might not agree with me on them, but just in my experience, these are the 3 things I see about data science and how it's applied that, resonate no matter what. So then we're going to talk about the dependencies, which are already loaded up front. We're just going to discuss what each one does. And then we're going to do a hands-on demo. And at the end, we're going to wrap it up with a conclusion, kind of talk about what we learned, what I see the future being for, talking about how we use APIs for machine learning. First thing I want to do is play this video. It's a great video from Silicon Valley about the hot dog, no hot dog. They have a lot of really great clips about machine learning, but I feel like this one really is the best about the current state of machine learning. So if you can't see the video or anything, please, let me know.
God. What will you say if I told you there is an app on the market?
We're past that part. Just demo it.
Okay. Let's start with a hot dog. Holy shit!
Yes!
It works!
Oh, motherfuck!
Huzzah!
Jin Yang, my beautiful little Asiatic friend, I'm going to buy you the palapa of your life. We will have 12 posts, braided palm leaves. You'll never feel exposed again.
I'm gonna be rich. Fuck you, Guilfoyle. Do pizza.
Let's do pizza.
Yeah.
Pizza.
Okay. Pizza.
Not hot dog?
Wait, what the fuck?
Eh?
That's it? It only does hot dogs?
No, and a not hot dog.
Okay, so I like showing this clip because a lot of times it really perfectly sums up the current state of machine learning. And it means that a lot of the models we have, they're only as good as the training data that we have. Sometimes you see a lot of companies try to, what I call, roll your own model. They think that their use case is so unique or so different, or their data set is so like one of a kind that they have to build their own model, right? Build their own model, build their own infrastructure, build everything from scratch. Like it kind of all has to be done like that. The message that I try to push across more often now as a data scientist is that it's not necessary in this day and age for everybody to build their own model and build their own infrastructure. I view it as no different than when maybe 30 years ago, right? 30 years ago, you were buying your own servers, you were setting up your own server racks, you're doing your own databases, you're laying your own network pipe, all those different things. So does anybody do that anymore? Some people do it because it fits their use case and what they're trying to do. Google, Facebook, Amazon, even Tesla, they're customizing down to the very chip level. Tesla introduced its own new machine learning chip specifically built for its use case. Google uses custom-made hardware and server racks. Amazon uses custom-built data centers just specifically for what they're doing. So there's always a use case for those things. But as the state of machine learning and data science progress, there's less and less of a use case where everybody has to go to that level to get benefit, right? That's why we use Amazon Web Services, which we'll be using today. That's why there's Azure. That's why there's Google Cloud. Why? Because those things have made it easier for us to interact and get value out of it without having to worry about some low-level functions that, previously would have to even use it. So we're gonna do a quick bio about myself. I use data science to help solve healthcare problems for the Army's medical department. I became a data scientist approximately 5 years ago. I came from a background of two things. One was more reconnaissance expert in the Army. So think about Iraq, Afghanistan, places like that. I switched more into data analytics, data analytics and IT work in general for the military. And then now I've kind of really transitioned the last couple of years to more of a purely data science type of role, where I try to help our department, help them retain doctors and other care providers, help them improve the quality of care we give our patients, and also help the executives get a better visibility in what's going on. So current role, data science. I know a couple of programming languages. By no means I'm an expert at all of them. I probably say Python and SQL are my two best that I kind of really feel super comfortable with. The other ones I feel comfortable, but obviously, I tell people I'm not an expert at any one particular thing. I'm a jack of all trades, and that's what most data scientists are. It's hard to specialize in one particular thing because sometimes you'll have to draw on different languages, different tools for different problem sets. I could be working in the same company for 10 years and all of a sudden this new question is being asked, or we have a different data set and now it requires a different tool that I have to quickly learn. And like everybody else, you have to learn quickly and you have to be able to get in there and jump in and start producing results. So some of the tools I use on a daily basis, not daily, but at least regular basis: Apache Spark, Apache Kafka, Airflow for data workflows, data engineering. At AWS, I personally use a lot of AWS, but obviously at the more government job, we use a lot of different things. Azure and AWS, good mix in there. Education, computer science, I have a focus on data science. For a little while, I dabbled in cybersecurity, so I have a graduate certificate in that. I also started off as a Bachelor of Science in Accounting. Interest, I like running. I like being out, not so much outdoors, but I just like being outside. Foodie, I always enjoy food. I really believe that it's one of the ways human beings connect best. I like building things, tinkering, just generally having fun with projects. I like startups. I like the energy. I like the crowd. I don't know if I could, ever fully be part of a startup, but I definitely do like to contribute towards startup efforts. I'm a father of three. I got two girls, one boy, and they pretty much keep me busy most times. Groups, I'm a very strong believer in diversity and inclusion, not just in the typical sense of how you look at it, but in a broader spectrum as well. Diversity of thought, diversity of background, diversity of, you know, just the way we do things. It's good to have that diverse perspective, because then we can solve more problems. At the end of the day, the more input, the more perspectives we have on something, the more problems we can solve, and the higher quality solution we can give. So I encourage you to be part of NumFocus. It's the same people that make a lot of the tools I'm going to be using. So if you've ever used NumPy, if you've ever used Matplotlib, if you've ever used scikit-learn, if you ever used Pandas, NumFocus is the overall umbrella organization that puts a lot of those tools out there. So it's not profit, but we always need help. We always like people to be involved. We always want people to contribute to the code, no matter what that means. That might mean documentation, or sometimes it might just mean kind of looking for bugs and, you know, letting us know about them. You can find me on LinkedIn, search for Luther Hill, GitHub, Luther Hill. All this code is already posted on there. It's posted as national security facial recognition, because this is a broader talk on national security. Now we're going to kind of cover 3 truths in data science, just to develop a collective framework of how I look at things and how I see a lot of these tools being implemented via API or really proprietary code. So data science to me has always been about human beings. Human beings is always more important than the data. You know, the data is always honest, but it might not be honest about your particular situation, which is a good way of saying that you need a human being in the loop to make that final determination of relevancy. Is it relevant to the question we asked? Is it relevant to our organization? Is it relevant to the problem we're trying to solve? And if not, how can I make it more relevant, more truthful, more, you know, pointed at what we're trying to solve? The second thing is more data equals more truth. Just generally speaking, the more data you have about a situation, the better off that result will be. Obviously, not all data is created equal. Some data is not as relevant to your particular problem, so it might skew your results. But once again, that's where a human being in the loop is important, because it helps you determine, is this data relevant to my organization? Does it even make sense? You know, a perfect example is we'll build a quick neural network to do addition, and you're like, wow, that, you know, really cool. Neural networks are cutting edge technology, and they seem really smart, and they're doing all this really cool stuff. So addition should be no problem for them. What we will see is that just because we feed a neural network a bunch of data, it doesn't mean it's going to come up with a better solution than a human would. Sometimes the solution is worse. So that's why you need a human being in the loop to make sure that you can identify when and where it goes wrong, because it will. It's imperfect. And then the third thing is your model is only as good as your ability to communicate it. So it doesn't matter if you're building off a fancy API, or if you're building, you know, working on your own pre-made model, or if you are, or just doing addition, or whatever it is you're doing, you're just counting numbers. Your model is only as good as your ability to communicate it. That's why I encourage data scientists to really work on their communication. Model building is important. Model serving is important. Scaling is important. APIs, proprietary, all those things are important. But at the end of the day, if you come up with a great solution, however that solution is implemented, and you cannot properly communicate to your organization why it has value, then those solutions are not going to get implemented, which means that those solutions are ultimately worthless, right? It's like a software engineer who can write great code, but the software engineer can't explain how he or she wrote the code. They cannot tell you anything about what the code is doing. Are you going to trust that software engineer's code? No, you're going to tell them, hey, you need to go back to the drawing board. You need to refactor it. You need to make sure you understand what it is you're doing. So that's important. You really have to be able to communicate your results. Data science generally is 3 different things combined. It's applied statistics, it is computer science, it is domain expertise. Applied statistics doesn't mean hard statistics, it doesn't mean calculus, it doesn't mean anything like that. It just means that you have to understand the mathematical concept at work. It doesn't mean you have to know backpropagation and calculus and all that stuff. It really doesn't. It just means that you have to know what is this thing generally doing? What kind of results should it be getting? So that way you can correct when things go wrong. Computer science is super useful because obviously all these things we're doing them through computer code. We're doing them through computer processes. We're using computers, right? So we have to understand how computers work. We have to understand their limitations and know how to compensate for that, either with more or less data, or a faster or slower algorithm, right? Or better or worse hardware. Sometimes, to be honest, faster hardware or better hardware does not solve your problem. Sometimes improving your code will solve your problem. Or sometimes really downgrading your hardware because the hardware itself is giving you so much spikes in terms of its processing capability. It's moving too fast that your software, your model is not built for that. So you really have to understand that. And then domain expertise, right? Domain expertise, that's why I said humans in the loop. Domain expertise makes sure that your computer, your mathematical modeling are relevant. If your model is spitting out ones and zeros, but your management team, your organization communicates in not ones and zeros, then there's gonna be need for translation no matter what language you speak, right? So that's where the domain expertise and the human in the loop comes in. They can make it relevant to human beings. All right, moving on, we're just gonna cover some quick technical notes about dependencies. So like I said before, I use Jupyter notebooks for this particular presentation, but really you can build this code in any kind of IDE that supports Python, Visual Studio Code. I would recommend using scientific mode. It creates an IPython window similar to Jupyter notebooks that gives you individual cells to execute code in, but it's not necessary. You can copy all this code into one big text and one big IDE file and execute it, with minor modifications, obviously. We're going to briefly talk about OpenCV. Obviously, this talk on, when you go to GitHub, will have a larger portion where it talks about OpenCV and open source imaging, but we're going to kind of limit that for the time right now. What we are going to talk about is AWS recognition. That's the main API we'll be using, but the concepts you're covering can also be used with Google Cloud. It can also be used with Azure and a couple other cloud vendors that provide machine learning or AI services as an API. Python packages used generally. We're going to use pandas for data frames, NumPy for arrays and mathematical modeling. Boto3 is really the big one for interacting with the AWS CLI, AWS command line, and also the AWS infrastructure in the back end. Scikit-learn for some basic data science modeling, Matplotlib for presentations, Seaborn for advanced visualizations, Pillow for images, Time for, you guessed it, time. Make sure we're all on the same time because we're talking to a lot of distributed systems, so we want to make sure that everybody is tracking the same time. Maththread for more basic lower level math functions, OS and sys for systems integration. Keras and TensorFlow, we're really going to be using Keras, which is a higher level abstraction of TensorFlow. So Keras is not what's processing it. Keras gives us abstract some of the really nitty-gritty detail of TensorFlow that make a lot of these things happen. OpenCV is an open implementation of computer vision. That's what the CV stands for, computer vision. Briefly, I want to kind of state a problem statement and then we'll solve it using APIs, right? So first things first, any sufficiently advanced technology looks like magic. If you think back to 30 years ago, this stuff looked like magic. Like you couldn't tell me 30 years ago we'd be using image recognition from our computers, talking to another computer in the cloud, or what was the cloud, right? So the problem that we have is we have, a general fear that our society is being monitored by a surveillance state, right? Whether it be a corporate surveillance state, whether that be a government or political surveillance state, right? We're wondering what technologies, what kind of software makes these happen? How do they do this? Like, how do they know where we are? How do they track our faces and different things like that? Some stuff in the news, some facial recognition that was in the news. I mean, I don't know if you follow it, but AWS recently got its contract not renewed, not canceled per se, but not renewed by Orlando Police Department because there was a backlash against using their API, which we're going to use now, called AWS Recognition. Same thing they used in Orlando, we're going to use now for building a surveillance state for the Orlando City Police, basically. And also the government, if you've ever been to any major airports nowadays, I fly out of Charlotte a lot, Charlotte, North Carolina Airport. And their airport has a queue by the TSA where you can, instead of showing your passport, you can stand there, the hardware will snap a picture of you, and then from there, it will determine if it's gonna let you through or not. They do that by matching, obviously, your passport and other photos with the information they have on hand. So that is another use of similar APIs. And I'm not sure what API they use for that, but I'm pretty much sure they're using an API for that. Okay, so now we're going to go down here. 1 second here, science of facial recognition, no. So what we're gonna do here real quick is we're going to build a neural network. That's the first thing off the bat. We're gonna try to understand, hey, how is this API? What is the APIs doing? How smart are they? What can they do? So we're gonna build a neural network. The code you see there will allow you to build a neural network. If you look at it, we're building a model. The dense 2 part is how many neurons we want in each network, right? So the first layer is gonna be 2 neurons, second layer, 10 neurons, third layer, 32 neurons, last layer, 1 neuron. And then the activation function is how are we going to activate this information? What kind of gate are we going to use? There's different kinds of functions depending on your use case. For images, I find the RealU function works better, but there's other things you can use too. So let's start here. Whoa, that's it. We built our first neural network. Now we have a blob, right? That's what I think about. We just have a big blob of, it can't do anything. We haven't trained it to do anything. It's just a blob of neurons. We're gonna just generally run a model summary. What does our model look like? We can tell that the third model is the densest. With 32 neurons, it can handle 352 parameters. The initial first layer of the neuron can only handle 6 parameters. That tells you how many data points it can take in and run. Now we're going to train our model. We're going to say that we're going to do a bunch, we're going to do, we're going to do basically 2,000 iterations of numbers between 0 and 5,000. We're going to teach the computer how to do addition. Let's run it. Just like that, we've trained our model. Now down here, we're actually going to use our model. We're going to ask for input, and we're going to ask for 2 numbers. Being that normally I would ask the crowd for input on this, like, hey, what numbers? But I am going to just propose my own numbers. I'm gonna look around my apartment and, okay, my clock, it has 2 and it has 32. So I'm gonna add 2 and 32. 2 is the first number because it's 232, right? And then 32 is the next number. Now let's look at what number the result is. The number result is 33.972073. And you're wondering, well, why is there 0.972073? And it's simple, because a neural network, like any other machine learning program, has a statistical backbone. And what do we know about statistics? It will never equal 100%. Statistics, probability, all that stuff will never give you 100% because it can never be 100% sure that anything is true. So how does that affect our addition? That affects our addition where we can, anybody looking at this can tell 32 plus 2 is 34. The computer, however, because it's doing probability, doesn't know addition. It doesn't know how to add anything or subtract or anything else. All it knows that the probability based on between 0 and 5,000 and running this scenario 2,000 times, the probability that 32 and 2 will equal to 30, it just does probability. So there's always going to be a slight leftover, which is important when you think about machine learning as a whole. You have to realize the computer is never going to be 100% accurate. It will never be 100% sure. It's going to have a threshold. It's up to the human being in the loop to determine what is that threshold, what is acceptable threshold to make a decision. And that's the key. It doesn't have to be 100%, right? A lot of times in our own personal lives, we don't ever have 100% clarity or accuracy on anything. A computer is no different. So remember that it will never be 100%, and you will see this as we go along. So I'm going to skip some of this stuff there. If you ever want to play some more data analysis when it comes to computer vision, you can run the rest of this. It's pretty cool, but we're just going to focus on the Amazon recognition part for now. Okay. So Amazon recognition, what is Amazon recognition? Amazon recognition is an API developed by Amazon that allows you to do image or computer vision without having to build it locally in your computer. So what do I mean by that? The traditional way image recognition, computer vision has been done is that we try to run it on our own hardware, right? Using CPUs, GPUs, or whatever, or Raspberry Pis. We try to run it on our own hardware. What I'm proposing is that the current state of machine learning, this is one application, computer vision, but there are other services from other cloud providers, from all kinds of cloud providers, including Amazon, that can do text classification, sentiment analysis, time forecasting, fraud detection, all those different things. So does that mean you'll never have to build your own model? No, they actually allow you to build your own model and serve it via APIs. But what it allows you to do is not have to build the roads. You can take up the fact that Amazon has pre-trained models. And as we go through this, you'll see the limitations of those models. You'll see where they really work, where they don't, and we'll talk about why they work and why they don't for certain use cases. So first thing we're gonna do, we're gonna import Boto 3, which we talked about earlier as being the Python package or Python wrapper for dealing with Amazon's, whether it be the CLI or the API services. pprint is just a really good way to print things. I like it generally because it does exactly what it says. It pretty prints it. It makes it look nice without a lot of me having to do the formatting. So first thing I'm going to do is just query Amazon for any buckets or any instances that I have available right now. As you can tell, I don't have anything set up. It's all kind of blank because mostly I'd just be using their APIs. I'm not storing or serving anything from the cloud. I'm just using their APIs and built-in models. And it's an important thing to remember is that by using their APIs, you're saying that you're sending them your information. So you have to remember that if you have sensitive information, whether it be for sensitive company information or sensitive privacy-related information or national security information, Amazon might not be the right choice, but they have a lot of really good HIPAA compliant systems. They do contracting for the government. So it's just really about making sure that you think about it before you just start sending data to the cloud effectively. You have to think about what kind of data am I sending? Is it sensitive? Is it proprietary? Just something to think about. So what I'm going to do here is, if you look at it, same thing. I kind of import Boto 3 in every cell, not because I have to, just because I want to make sure that I don't time out or something happens. But generally, you don't have to do it this way. So what I'm saying is I'm telling Boto 3, which is the Amazon Python wrapper, hey, I'm calling this service called recognition. So I'm creating a client for recognition. I could even if I'm using more than one AWS API, I can use multiple clients, just have to name them differently. It might be recognition client, whatever it might be, but it's up to you. And what I did here is I didn't create it, but if you copy and paste this URL, it takes you to a photo. You can really slap any photo in there. However, you can actually use locally stored photo too. So locally stored photo, you can store photo in an S3 bucket, or you can use, like I did, just a generic website. That way you can go make sure the photo is real and I'm not just hard coding a solution. And then what I basically did is I took that photo, I sent it to Amazon's API, and I asked them for some information. I said, hey, I want you to use out of Amazon recognition, I want you to use the celebrity faces function. I want you to give me back the name. I want you to give me back the confidence level. How sure are you that it's the person you're saying it is? And I want you to give me back the URL where I can basically confirm your information. Like, how do you know who this person is, right? We'll run it, and you can tell this little asterisk is running. That's the photo we used. Let's see the results. For just in case you think this was already done again, let's do it again. So it's running, and running, and now we have it. So when we look at this photo, right? Now I don't know about you, but I'm a big Ryan Reynolds fan. I love Deadpool. I love all the heck. I haven't loved Green Lantern. People hate on Green Lantern, but I love the movie. I love it. It was great. So, but we have a couple of actors there, right? And actresses there. Now look at the results it gave us. It gave us the one person it was the most sure of was Channing Tatum, which I always say Tannen. I never get his name right. But even most sure, it was only 99% sure, right? Remember what we talked about, it's never going to be 100. You cannot set a parameter for 100% sure because you will get 0 results. So we have anything from 99% sure to 61% sure for Mitch McGarry. I had to look up Mitch McGarry, and I'll tell you there's no Mitch McGarry in this picture. I don't know how they got Mitch McGarry, but they got Mitch McGarry. But it's at 61% confidence. And notice there's also no website associated to it, so they couldn't give you the information to say, hey, this is where we got the source of truth. So that might be something to think about, right? For your particular use case, you might need, if you're working something in national security, you're really going to need 95% positive rate. There's no way you can misidentify somebody. You have to be correct. And even then, you might want a human in the loop to spot check it. So, okay, Brianna Hildebrand, confidence 100%. Yes, it's 100%, but it's never 100%, right? We know that. Oscar Isaacson, 61%. So once again, you might even select the range. You might be like, okay, I will only accept things that range from 80% to 90 to 80+%. Or if you really want to go wide and say, okay, you know what, just kind of show me everything. You might say, I'll take anything that's at 5% or above. It doesn't really matter. You can set it any which way you want. Now, if we look at the picture and we look at the percentages, we can identify a couple of key trends here, right? So why did it identify Hugh Grant? Why did it not identify Ryan Reynolds? Why did it misidentify Mitch McGarry, which I think is that guy on the far right? And why was the match for Channing Tatum and Brianna Hildebrand and Oscar, Philip Boback, so high? If we look at it, why do you think that is? The common denominator there is one, Channing Tatum's face is straight on looking at the camera, well lit. Same thing if Brianna, her face is straight on looking at the camera, well lit. Oscar, is it Oscar Isaac? What is his name? Oscar Isaac. His face is a little bit more in the back, right? He has a funny face. He's making a funny face, so that might throw some of his facial features off. Hugh Jack resulting in a lower match rate. Hugh Jackman, his head is tilted out of the outward angle, making a funny face that might have thrown it off. Ryan Reynolds, there's clearly a shadow on his face. His also head is tilted. You don't really have a full frontal look at him. So all those things affect it, right? Lighting, all those different things. But we can tell that we did not have to code this in our machine. There's no way I could have built a model like this to do all the facial recognition and serve me back a result in 15 lines. On my own computer, there's no way. Even if I had just built just called a bunch of imports and then done a bunch of functions, it probably still would have taken me more lines. And let's face it, I would have still had to hard code all that stuff. It would have to reside on my computer somewhere. But the only thing that resides on my computer is 15 lines of code. And to be honest, the first 3 I don't really need in this particular thing because it's already imported into the system and there's a bunch of spaces. So for readability, I did the spaces, but I don't have to. So really, I could probably say that 10 lines is of code is all I actually need to produce this. Versus if I built it myself, you're looking at a couple hundred lines of code plus computer power, time, everything else. Okay, we're gonna move along. So take an eye on this picture. If you look at this picture, what are you seeing? You're seeing different faces, right? Just take a look at it. You're seeing glasses, you're seeing flags, you're seeing what at face value might appear to you to be angry people, or they might be happy, or they might be sad, or they just might be confused, right? But there's a spectrum of emotion in there, let's say that. Let's figure out what first of all, let's see how the computer identifies these people, right? So we're gonna run this code, same thing. We're gonna tell Amazon, hey, here's a picture, here's the website, we're gonna serve it the picture, and then we're gonna ask for the picture back. Can everybody, you know what, I just need some kind of voice to let me know. Can people see the picture I'm posting right now? It should have the same picture, but with bounding boxes over it. Anybody?
Yeah.
Yeah? Okay. All right, cool. So that picture right there is the same as before, right? But this time, what did we tell Amazon? We asked the API, hey, API, give us the same picture, but we want you to identify the faces that you see. So it spotted a lot of faces. Some faces are full frontal, some faces are hidden, right? Like if we look on the left side, the guy on the left side, the second from the left, I mean, I can't make out a face there. I can make out a hat, I can make out a blob, I can make out a shadow, but I can't really make out a face. So it gives a pretty good, it's pretty good at identifying faces, let's say that. And how do we do that? Same thing, we called Bodo3, we called Pillow for our pictures. And then, we asked it, hey, take a look at these pictures using something. We created a client for Amazon recognition. If we were using like text analysis, we'd create a client for something else. And we said, here's a picture, here's the image URL. We sent it to Pillow for processing. We appeared, and then we send it to Amazon, and we said, hey, Amazon, give us back a picture give us back the coordinates for the bounding boxes. And then we plotted the image, right? And that's the image we got. We used the API to identify faces. And same thing, right? Look at the limited amount of code we had to use. On top of it, we did not have to use our own processing power or computer or speed or be limited by our network or anything else. So it's pretty cool. All right, I'm gonna kind of shoot through this stuff. I noticed we're running low on time. So we did facial detection, and then now I'm going to, so if you look down, you'll see some results pre-populated, but I'm gonna run this code again so you can kind of see the time it takes. This one, on the other hand, is gonna take about 20 seconds. Why? Because we're asking for a deeper level of service. We're asking for, what are we asking for right here? Face details. We don't just want the amount of faces, we want details about those faces. What do we want? What kind of details do we want? We wanna know, is this person wearing a mustache? Do they have a beard? How old are they? Are they wearing sunglasses? All those different things we want to know. We also want to know their gender, their age, is it, and the age range, and what kind of emotion are they showing? Happy, sad. Now we kick back the result. Based on, I'm just going to scan back to the picture. Based on this picture, when we sent it to Amazon, through the API said, hey, this is the results I have. I found 16 faces. I found males aged 23 all the way to 38. I found one female face. Well, actually 2 female faces. I found one person with glasses. I found people with beards. I found people that look calm. I found people that look angry. This is really advanced recognition that we're doing with minimal code through an API. Now, you don't have to use this for national security. You could use this for, if you're a sales rep in store, you could scan the crowd and see, are they engaging with me? Are they buying what I'm selling? If you're a teacher, you could be monitoring your classroom and figuring out which student is not engaged in the material, and then go give that person help. Versus what you might be doing now is like you might have your back turned dealing with one student, not realizing that somebody in the far corner of the room is not engaged in the material. So this allows you to do that. Now what we're going to do is we're going to read labels. We're going to ask Amazon, show me the objects you have in this. If you look at this, you can clearly see there's a bunch of guns. There's a bunch of weapons, and you would think that Amazon would pick those up relatively quickly, right? So here, you have some pre-populated results, but we're going to run it again. So now if you look down here, and one other thing I want you to take a look at, I set the minimum confidence level to 40%. So I said anything that is above that is above 40% confidence, show it to me. And when we look at the confidence of weapons, let's look here. So Amazon is 98% confident that there's a person in the crowd. They're 94% confident that this is a human. They're 87% confident that this is an actual crowd. Let's see for our weapons. Military, 59% confident this is a military unit of some kind. They're 53% confident it's a soldier. And they are 44% confident that it is a weapon. They actually think that it's a higher probability that it's a video game than an actual weapon, right? Gun, they're only 42% confident that it's a gun. So we can tell the limitations, right? And you're not, I know what you're thinking, how can Amazon not tell, how can they be only 43, 42% confident that there's a weapon in here? And the reason why Amazon's use case is not based on national security, it's based on general public needs. So how does that affect you and your use case? If you're using this for a very particular use case that is not generally applicable, you might want to add your own training data. There is a way for you to feed training data to the model for your specific case, but it might not be right that you just use the general model because it's not. So that's why the testing has to come into play so you can know what model to use if you need to supplement Amazon's model with additional data for what you're doing, right? And then moving on, this is a quick manifesto of some person I found online, and you can read it. It's pretty clear. Not all text is this clear, but we used it for purposes of the demonstration. So you might imagine a police officer or even a customer call center, right? You have all these reviews you're trying to read through, or you have all these different reviews on Amazon you're trying to read through. What you want to do is be able to parse out just the reviews that are applicable to you and your company, and then do further analysis on those. So what we're going to do is we're going to, same thing, tell Amazon, hey, this time I used actually the S3 bucket named Rosa Dominica, and I uploaded a JPEG in there called Manifesto, which is what we saw. And I told it to run the analysis and give me back the text. And notice all this text is in JSON format. So now you take what was effectively a picture, or it could be a PDF, could be a handwritten note, and you take that and now you're getting code. You're getting JSON strings that you can further evaluate for other things. So you might now want to say, hey, I want to now run sentiment analysis on it. Or maybe I just want to do a word blob, or heck, maybe I just want to take those raw reviews and put it on my website as customer testimonials. And instead of you having to pay somebody to parse through a handwritten letter or go on every website and look for it, you can just have Amazon do it, lickety split. And on top of it, you can constantly update those reviews. So do you want the same customer seeing the same reviews for 10 years? No, you want to update those. You could even further specify it. Maybe you say, hey, this letter or this review came from this particular zip code. I have a customer who's also coming from that particular zip code. Let me put that review on my website as personalized service for when they load it. It makes their recommendation, it makes the review more relevant to that customer. It builds trust and confidence in your product. So all those different things you can do, through creative uses. And, you can do all of that initially with really about 25 lines of code. How amazing is that? In JSON that you can use for different things. All right, I'm not gonna go into this video. I know we're running short on time. I'm gonna briefly play this video just to kind of, for a couple of seconds, to highlight what the future might look like, and depending on your point of view, it might be good or it might be bad. But everybody has a point of view on it. So if you look here, we can tell that he's walking through and he's doing personalized. All right, okay. So just quickly, I mean, we can tell that this technology has great potential, but also a lot of really pretty disturbing use cases. And that's why I want to kind of conclude with, it's really up to us as tech professionals to be informed about this technology, to be informed about the use cases, and to be able to communicate that with our society, our family, and our friends, and also the people we work for. So what does that mean? You know, it might mean that, you know, we engage the company about like, hey, is this really an ethical use of this technology? Or it just might mean that we engage them like, I see that you want to implement some kind of machine learning data science, but you're talking about a build process that might involve 6 software engineers, 6 months of work, thousands of dollars, and then not have a product that's any better. So this is a way to speed up that cycle. Some other things I want to leave you with are, one, I think generally people will want to be more connected in the future because we always want to be more connected. I think that they'll want an increased level of personalization. And I think that, you know, this technology will be abused. It's like anything else, it will be abused. But I would hope that as technology professionals, we can stay educated and educate other people how to properly use this technology, right? Like Stan Lee said, with great power comes great responsibility, and we want to use it wisely. And I'll pause there for any questions or comments. Yeah, thank you very much for the opportunity to speak.
We really are glad to have you come out for this. There was one comment that Malcolm Newmeyer gave. He said, good context for this discussion. Most of the time we leave out the people factor. And yeah, it's of critical importance, I think. I think you were right on in like giving it as much focus as you did.
Yeah, definitely. I'm a big believer in that. A lot of machine learning, quote unquote, data science is not going to replace human beings. It's going to make us move faster, meaning that we are no longer going to be able to wait to make decisions months and months later, gather all this data, wait and wait and wait. We will have the ability to collect data in near real time and analyze it in near real time, which means that we have to make quicker decisions. But that might be a good thing, that might be a bad thing, but that's why I firmly believe that we have to keep human beings in the decision-making loop, because at the end of the day, those machine learning algorithms will be impacting human lives. Mm-hmm. I think having human beings in the loop, being informed by the data, being informed by what metrics and things and technology we have, but ultimately we need to make the decision.
Cool. Yes. Yeah.
Reach out to me. I love engaging with the community. I love sharing knowledge about it. Whether you want me to talk about maybe other APIs and other uses of it for machine learning or data science, or if you just kind of want to talk about more of the ethical side of it, of how to best use it, how to think about it, or how to communicate with your company about it. Yeah, for sure. Reach out. LinkedIn is probably the best way to reach me. Just search for Luther Hill in Louisville, and you can find me on there. That's probably the best way, Luther Hill on LinkedIn.